So let's look at one more example in this section. Let's analyze and sketch the graph of the logistic function f of x will be 1 over 1 plus e to the negative x. So the domain here, start with the domain, start with the domain. Well, we can plug in any value of x because the denominator will never be 0. So the domain is negative infinity to infinity. If I look for my x-intercepts, that's where I plug in y equals 0. Well, there's no solution there. So there are none. The y-intercepts, well, the y-intercept, if I plug in x equals 0 into my function, you get 1/2, so the y-intercept is 0, 1/2. Because the denominator is never 0, I have no vertical asymptotes. There's none. My domain is negative infinity to infinity. But I do have horizontal asymptotes. And if you remember, this was a problem we saw earlier in the last section. So this one had different ones on the left and on the right. On the left, it was y equals 0. On the right was y equals 1. So now, I'm going to look at my function, look at the derivative. So here, my function, if I rewrite it, it's 1 plus e to the negative x to the negative first, and do the chain rule. F prime of x will be negative 1. And then the derivative of the inside, which is e to the negative x times a negative 1. So it'll become a positive e to the negative x. Oop, our power went down by 1, so this should be a minus 2. E to the negative x over 1 plus e to the negative x squared. So the denominator, again, won't be a 0. The smallest this inside part could be is 1. If I set this equal to 0 and solve, you set the numerator to equal to 0, there's no solution here. So that means we have no critical points. Now I'm going to find the second derivative. Here you're going to have to use the quotient rule. So if you use the quotient rule and simplify, you should get something like this. You should get exactly that. And so then we look for our inflection points. Again, we're going to set our possible, they're not guaranteed to be, inflection points. So you're going to set the numerator equal to 0. Well, e to the negative x equals 0. This has no solution. E to the negative x minus 1 equals 0. If you solve that, then you know negative x must be 0 because e to the 0 is 1. So x must be 0. So the only possible inflection point I have is x equals 0. So now that I've got all my information together, I'm ready to make my sign charts here. I'm only going to mark 0 on my number lines. So if you plug in a test point, like negative 1, 1, into your first derivative, So remember your first derivative was e to the negative x. The denominator is a square, so it's always positive. So then look at your numerator. If I plug in -1, it'll be e to the first, which is positive. If you plug in 1, it'll be e to the negative first, which is also positive. So here I learned that my function is increasing. It's always increasing. If I plug in -1 and 1 into my second derivative, if you plug in -1, you'll get that it's positive. If you plug in 1, it's going to be negative. So this will be concave up here, concave down. So we do know that we have this inflection point, at this right here, this is an inflection point. So we're ready to sketch now our curve. We have no vertical asymptotes. I do have two different horizontal ones though. Y equals 1 and y equals 0. Okay, that's, and then I had this intercept 0, 1/2. And so my function, remember, it's always increasing. It's always going to be increasing, but it's going to start concave up. So concave up looks like this, right? So I want it to be concave up and increasing. So it goes like that. But then it's going to switch. It's still going to be increasing, but now it's going to be concave down and increasing. Looks like that. So there is a rough sketch of what the graph of this function looks like.